is what underpins all of our contaminated land regime regulatory controls here in the UK. But unique to ground gas contamination, there's a fourth factor which the public inquiry identified, and that was a driving mechanism. And in this case, at LOSCO, the driving mechanism was a weather system which passed over the country. A low pressure system came in over Derbyshire, and the atmospheric pressure dropped by over 20 millibars within a 6-hour period. And that drop in atmospheric pressure set up a differential between the landfill gas pressure in the ground, in the former landfill, and the atmosphere around number 51 Clark Avenue. And that differential effectively sucked the landfill gas through the pathway and into the subfloor void of the property. And when the central heating system tripped in at 6:30 in the morning, the explosive mixture was ignited and the house was destroyed. But that was back in 1986, almost, well, coming up to 35 years ago. But since then, there's been a raft of guidance documents on how to monitor, how to risk assess ground gases, but we still have incidents occurring. And one of the more significant or more serious incidents took place in Scotland in 2013. And this was a modern social housing estate built by Midlothian Council in 2009. But unfortunately, in September 2013, a number of the council tenants were overcome by gas. They were rushed to accident emergency, and the affected properties were evacuated. Because other people on the housing estates were also affected over the following months, by April 2014, the local NHS trust set up an incident management team to investigate what was going on. And their findings identified the source as being shallow mines gas from shallow mine workings immediately beneath the estate. In 2016, the local authority came to the decision to actually demolish the whole estate and start again as a way of treating the problem. None of the properties had ground gas protection systems installed within them. I should say that there was a number of court cases, and the leading consultant who led the development actually ceased trading as a consequence of illegal actions. So what are the hazards we are looking at? Well, in the case of Gorebridge, it was asphyxiation from carbon dioxide rich mines gas. In the case of LOSCO, it was an explosive mixture of landfill gas, predominantly methane. But there's other gases, carbon monoxide, which in very low concentrations is a toxic compound. We've got carcinogenic VOCs, and then we've got the radioactive radon, naturally occurring radon. And we fall into two categories. These which can have an acute risk, which is realized in very short periods of time, minutes or hours, and then the others which can accumulate over long periods of time. So here we've got two problems to deal with when we consider ground gases. We've got percentage scale concentrations of the bulk gases, such as methane. That's explosive between 5 and 15% by volume. And then we've got toxic compounds like hydrogen sulfide or carbon monoxide, where we're looking at toxic concentrations at parts per million scale. And then we've got different time scales of the hazard being measured in minutes or hours, or in years, or in some cases, decades. So quite a range of challenges to consider. So let's look at some of the properties of ground gases. And by way of illustration, I'm going to compare ground gases with some of the other contaminants that you may be familiar with. Take a solid contaminant such as asbestos. If that is placed in the ground and is left undisturbed, it will stay where it is. Liquid contaminants will flow down to the water table and then flow down gradient. So they have a predicted plume of contamination which flows down gradient and can be modelled and predicted. However, ground gases can expand and contract and potentially move in all directions, so much more variable than other forms, and more so because of their viscosity. The viscosity of water is given there, but of air or ground gases, that has a viscosity which is 50 times lower, which means that it can move through the ground quicker and go further than an equivalent liquid contaminant. So how does ground gases move through the ground? Well, it's got three forms or three modes of transportation. We have that advective pressure-driven flow, as we saw in LOSCO. We have a diffusive flow where it moves from areas of high concentration to areas of low concentration. And that typically occurs around sources of contamination, such as former landfills. And mentioning landfills, the Environment Agency has calculated that there are probably 21,000 former landfills in England and Wales. Every town and city will be surrounded by a ring of those former landfills, and a lot of our work is associated with them, particularly as new development expands out from where towns used to be or cities used to be, and as they grow out, they move on to areas which were thought to be out of sight, out of mind. Those former quarries, those former gravel pits that have been infilled with waste, those are now in prime development locations and are often a major cause of ground gas contamination. So those two modes of transport occur in the unsaturated zone above the water table. But we also can get gases dissolving into the groundwater and travelling down gradient in the groundwater below the water table. So those give us the three modes of transport. So let's look at that source pathway receptor pollutant linkage in a little bit more detail. In line with British Standards guidance, BS 8576, where ground gases are expected to be present, it is required that a conceptual site model, including a schematic cross-section, is presented as part of the risk assessment process, so that the sources, the pathways and the receptors and relationship between them can be clearly identified and more importantly communicated to all the stakeholders, which may include non-technical people. And a diagram such as this is a way of clearly defining or describing the issues that are involved. With regard to risk assessment, there's a number of tiers that can be considered. And tier 1 risk assessment is the simplest, which is there a credible contaminant linkage, a linkage between a gassing source and a potential receptor. Then we go through generic risk assessment tools and then finally detailed quantitative risk assessments. But for all of these, what we need are multiple lines of evidence to feed into that so that we have confidence in the decision-making process. So let's look at sources in a little bit more detail. And the two factors that we are concerned with are gas concentrations and gas flow rate, or, and put it in other words, the gas generating rate or the volume of gas that may be present in the ground. And sources may include, for instance, a modern licensed landfill where you've got containment systems in place, gas extraction systems and gas management systems. And putrescible waste, household waste in these sorts of landfills will be generating landfill gas at a concentration of 60% methane, 40% carbon dioxide at a rate of 10 cubic meters per ton per year. So when you've got a 50,000 ton landfill, that's a lot of gas which is generated and has to be managed safely in some way. At the other end, the other extreme, we have natural deposits of organic material, such as peat deposits. And these will also generate ground gases. Peat, specifically when it's waterlogged like this, will have anaerobic conditions and be generating methane at concentrations up to 90% by volume. But it will be generating it at a very, very slow rate. So the volume of gas which is generated is very low. As a consequence, people who live in peaty areas or where there's organic soils present which are waterlogged, they're not really at risk. So everyone who lives in Somerset, on the Somerset levels, they've been safely living there for decades, if not hundreds of years, despite methane being generated beneath their feet. And then we get the former landfills. And these typically are falling between those two extremes. A lot of them date back to the 1960s and 1970s, when the Clean Air Act prevented households from burning, having open fires as their means of heating. And all those newspapers and potato peelings, which were hitherto put on their domestic fire, were then collected as municipal waste and taken to those convenient holes in the ground beyond the town boundary. This is why we have so many of these former landfills, 21,000 of them. And then we have brownfield sites, those former industrial sites where there may have been some landfilling in the past, either deliberately within the curtilage of the factory or by accident, spilled contaminants, spilled chemicals which are soaked into the ground. And they may give rise to sources of VOC as well as methane and carbon dioxide. But also not forgetting another major source of ground gases, and that is our coal fields. Perhaps not so important in Hertfordshire, but elsewhere in the UK, coal fields are extensive and have been actively mined at shallow depth across large areas. Indeed, 11% of the footprint of Great Britain is actually underlain by coal fields. So a significant number of people live in and over these former mining areas. So let's look at pathways. And here we are looking at identifying potential sources of ground gas, either naturally occurring or often man-made or often landfill gas, and understanding what the site geology is and how the gases may be migrating through permeable strata to reach a receptor. And that permeable strata may be sedimentary deposits, but also may be rock deposits, fractured sandstones, fractured igneous rocks, even things like basalt can be a pathway for migrating gases. The receptors themselves also come in different shapes and sizes. We can have residential properties, and they are often considered to be the most sensitive because people may actually be occupants of those buildings for 24 hours a day. Business properties, commercial properties, they're usually only occupied for the working day, perhaps 8 hours. And as a consequence, they have a different risk profile. But we should also consider construction site workers as holes in the ground, excavations. They can also represent confined spaces where ground gases can accumulate, particularly carbon dioxide. And carbon dioxide is a particularly nasty toxic contaminant and asphyxiant, which is heavier than air and can accumulate in these below ground excavations. And unfortunately, over previous years, many construction workers have been killed by asphyxiation by going down into excavations filled with carbon dioxide. So moving on, let's talk about how we monitor and risk assess them. And the principal tool is a monitoring well. And a monitoring well is a scientific instrument that is constructed within a borehole. Now, drillers are paid to drill boreholes, and if they are encouraged, they will build a monitoring well inside those boreholes to a specification such as this, where you've got a top seal, bentonite seal, slotted response zone section, and a bottom seal, and hopefully a sand filter pack around that response zone. Sometimes there'll be shallow groundwater, and the shallow groundwater may also be present within that response zone. Monitoring takes place in the headspace above the response zone, in that plain pipe section, through a gas tap which you connect to your monitoring device. The groundwater level is also really important, and if you think of it changing, if it rains, the groundwater level may come up as rainwater percolates down to the groundwater level and increases, making it rise. The rising groundwater level will act like a piston on any gases in the unsaturated zone and pressurize them and force those gases into any overlying structure which may be present. So understanding and measuring the depth to the water table is also a really important part of ground gas monitoring. So the point I really make to all my audiences is that monitoring wells are scientific instruments which need to be carefully designed, with a response zone designed to cover the depth of interest or the strata of interest on a site-specific basis, and not only carefully designed but carefully installed. Unfortunately, a lot of clients don't pay for supervision or quality control of the installation process, and we get poor installations which are less than ideal. So how do they work in practice? Well, the monitoring well is constructed within a vertical borehole, so it picks up laterally migrating gases, and those gases which travel laterally are are passing through different sedimentary deposits, whereas for buildings that we are interested in risk assessing or ground gas risk assessing for a new development, they will be exposed to vertical migration. And the vertical to horizontal migration permeabilities may be different. So the consultant needs to understand those. The main problem is that the monitoring is carried out at a point in time, but after the monitoring has been completed, there may be site enabling works which actually change the gas regime. There may be the sites may be re-leveled, there may be more fill material brought on, there may be excavations taking place which cut through those sedimentary layers and introduce potentially preferential pathways for migrating gases. So this is something which, again, is a pinch point in a lot of consultants' reports. And then the boreholes themselves, if the boreholes are left intact, they can act in themselves as a preferential migration pathway directly under a development. So let's look at monitoring in a little bit more detail. Here's a picture of a monitoring well, and the traditional method of monitoring would be to use a handheld device, and there's a whole range of different devices which may be on the market. And someone traditionally would go to this borehole, go to site once a week or once a fortnight and take a reading from the monitoring wells present. And those readings would be typed up onto tables where each row represents a different monitoring well and each column is a different parameter, concentration of methane or carbon dioxide or trace gas such as hydrogen sulfide, etc. So every week another table would be created, and another table, and another table. And it was a difficulty that such tables gave to the risk assessors and to regulators, that in 2006 I looked at collaborating on a research project to look at a better way of characterizing ground gas. And that was successful. We got GTI funding to carry out the research. We set up an expert advisory group of some of the key names in our sector. And in 2009, we actually developed the first in-borehole continuous ground gas monitoring device, the gas clam. And it was on that step-changing technology that I actually set up GGS. So in 2009, we had that first generation in-borehole device, the gas clam. And subsequently, we've got other devices on the market. At GGS, we are gradually moving over to gas sentinels, which are smaller, lighter, smarter instruments and give us better quality information. So what is continuous monitoring? Well, the definition of continuous monitoring is monitoring carried out by an in-situ device that records time series data at a monitoring frequency that exceeds the frequency of change of a measured parameter. And typically we set our instruments to measure concentrations and flow on an hourly basis. If we think back to the LOSCO event, that occurred because the atmospheric pressure dropped 20 millibars in 6 hours. So for traditional spot monitoring of going to site once a week really is not helpful in identifying the true risks at a particular site. But by continuous monitoring on an hourly basis, we can see the full range of variability through time. But the real value of the technique comes by looking at its correlation with some of the other parameters, atmospheric pressure, temperature, changing in water levels, etc. And seeing relationships where every time there's a fall in atmospheric pressure, we see there's a spike in ground gas concentration, gives us confidence that we actually are seeing something of importance for this particular site. And we can use this for generic risk assessment techniques, calculating continuous gas screening values, looking at conceptual characteristic situations, different concentrations of gas. So we can see in this case that on this particular borehole, we've got gas concentrations spiking up into characteristic situation 3 conditions on occasions. Is that significant? Well, we need to look at other lines of evidence to understand the significance. So when is continuous monitoring useful? Well, typically when there's uncertainty. So if you have spot monitoring data, which every time you go to site, you see that there is a hazardous gas concentration, you know you've got a problem which needs to be dealt with. It's more difficult to make decisions when you see data like this, where sometimes there's a gas present and sometimes it isn't. On those circumstances, continuous monitoring can be really helpful. So let's look at gas protection systems. And in the UK, we have a very simple approach to protection. We look at diluting and dispersing ground gases by providing a preferential pathway to atmosphere through typically a subfloor void or a granular layer beneath the floor of a new building, and excluding the ground gases from the living space. So a two-pronged approach, two techniques go hand in hand in protecting new development. So in respect of the membrane, that will go over in a residential development, typically will go over the block and beam floor and cover the cavity wall out to the edge of the building, and the subfloor void and vents allow any gases which accumulate underneath to be safely vented to atmosphere. And what's important is that these two elements are installed adequately. And here we have a photograph of a qualified installer heat sealing a gas-proof membrane into a residential property, and you can see how he's sealing a membrane across that cavity wall. So this leads us on into validation, or verification as some people refer to it. And this is the final piece in the jigsaw, really. We investigate ground gases, and these are some of the reference documents covering that element. We risk assess, and we design, and then we install. Verification is covered by this guidance document, Syria C735, which was published in 2014. And that throws a focus on the installation. And installation is the one element which can negate all the other work that has been carried out. If it isn't installed properly, all of the investigation, risk assessment, design work is done for nothing. So focusing on verification, these are the two documents which set out what needs to be done. And BS 8485 makes reference as a nominal reference to that. It's a technical document which gives scoring points for different types of risk, for different types of development. But the point is that the requirements for gas contaminated sites, certainly of CS3 and above, you need an independent verifier, you need a verification plan, you need a verification report. And best practice would require a qualified installer and a qualified verifier. What is a verifier? Well, C735 sets out that a verifier should be a competent, experienced, and suitably trained person who has immediate access to appropriate technical support where needed or necessary. And the emphasis there is on an independent third party. Unfortunately, all too often, you'll find that there are companies which pair up and they will offer verification services for their partner company. I'll do yours if you do mine. And that is not an independent, impartial verification process. And you need to keep your close eye on who is doing the verification. So please try and avoid that. So what does some of the problems look like? Well, this is a verified gas membrane. One of my colleagues, my technical director, John Naylor, did a verification report on this development for these particular plots. And he was invited back a few days later to verify the next plot along. And he saw this. It's a full line-out gas-proof membrane, which was installed and verified. But if you look at the back of the photo, you'll see that the follow-on trades have started putting in the steel reinforcing. The steel reinforcing was cut to length in situ. And by cutting the steel in situ, they put something like 500 holes in the membrane. So John had to retract his verification certificate for this property. Basically, the gas-proof membrane was trashed by the follow-on trades. And this happens very, very, very frequently, unfortunately. Here's another example. This is a different type of, again, it's a residential development, but a different type of scheduling. Here, a picture frame and infill membrane design was used so that the vertical walls could be built up over the membrane, and then once the roof, the walls and roof had been put on, the internal rooms could be sealed by another membrane which was fitted out and sealed to the membrane under the walls. Unfortunately, they have put a membrane in that didn't seal around the service entries, and the service entries by their nature represent a direct gas ingress point. Also, the membrane sheets were not sealed together, they were just loose laid under the walls, and they put a scaffolding pipe on the membrane, and that in itself has damaged the membrane. Here's another example, which is typical of an unqualified installer. It's a good quality gas-proof membrane, yes, but he has no thought of how the membrane should be sealed around that internal wall. But the mortar has been left all over the membrane and all over the floor. So anyone coming into this is likely to damage the membrane by walking on and pushing the mortar through and puncturing that membrane. And also, with all that mortar there, it's almost impossible to install an infill membrane and seal it successfully to it. So looking at commercial developments, larger footprint buildings like warehouses, another frequent problem is laying a membrane on unsuitable subgrade. Sharp stones have been left and the membrane is just being rolled out directly over those. So if anyone walked on that, it's likely that those sharp stones are going to puncture the membrane, as you can see there. Or they put a membrane in, it's been verified, and then they track machines over it. So vehicle damage, a concrete mixer driving onto that membrane. And not only that, driving onto reinforcing bars, which are punctured down into the and through the membrane. Takes a lot of time and effort and quite a stiff constitution to deal with the contractors in this situation. But there is a get out of jail card that can be played by developers if they know that the gas protection measures have not been put in properly or haven't been properly verified, or they don't have appropriate records. Then we can do continuous monitoring, receptor monitoring, such as looking at monitoring the subfloor voids, actually monitoring it like a full-scale flux box test to see what are the actual gas concentrations underneath the building. Okay, I'm going to finish off this section by this newspaper article, which I'll just give you a moment or two to read. Here we have a professional person, a site project manager, who thought he could bypass the regulatory requirement for a verification report by cutting and pasting old validation certificates into his new site. Unfortunately, fortunately, he was caught out and was jailed for 7 months. These gas-proof membranes, the validation, the verification reports are designed to protect the end occupants of these buildings, and the hazard is potentially fatal if you get it wrong. So it's really important that all of the steps are taken seriously and carried out. Okay, for the last few minutes, I'm going to talk about radon. And to a large extent, this is an overlooked hazard, but potentially the most damaging or most dangerous ground gas of all of them. It is a large atom. It's got an atomic number of 86, atomic mass of 222, and it's a radioactive gas which has been created by the radioactive decay of uranium. And uranium is a naturally occurring metal, typically found originally in granites. So the granites around Cornwall, under the West Midlands, in Wales and in Scotland are the source rocks, original source rocks. But because granites weather and the minerals within them weather out into the sedimentary rocks, almost all of the geology of the UK has uranium in greater or lesser concentrations. So when you ask for or look at radon maps, I'll give you an online link to where you can find this data. You'll find there's a very close relationship between the radon concentrations with the underlying geology. But these radon maps are at best indicative. You know, I'll say why that's the case in a moment. So it's a naturally occurring gas. It's very heavy, but it is radioactive, and it enters buildings through the same cracks and pathways that other ground gases get in. In addition, it is very soluble in water and can actually get into properties through water supplies if there's a private water supply present. So comes through cracks, service entries, etc. Occasionally, not so much in this country, but certainly in Scandinavia, building materials themselves may be a source of radon. The actual radon concentrations in the house themselves, though, are affected by a whole range of factors. The weather, in particular temperature, rainfall, wind speed, and also the time of year. And it's very site specific. It's how the main hazard is the occupants of houses. So those occupants who tend to leave their doors and windows open because they like fresh air, the radon will be dissipated quite safely and they will be at low risk. But other people, particularly in this day and age where we are looking at trying to conserve heat, keep our fuel bills down and keep all our windows shut, that's where the greatest hazard will occur. So it's how people use their houses that determines the greatest risk. And the risk comes from radon being breathed in. And it has a very short, because it's radioactive gas, it has a half-life of, a very short half-life of just over 3 days. But as it's a gas, people breathe it in and then breathe it out. Unfortunately, if they breathe it in and it decays, it will decay to another radioactive daughter product, which is a heavy metal. And that heavy metal will lodge in your lungs and stay there. So from the lungs, it will travel into your bloodstream. The decay throws off alpha particles, and it's those alpha particles within the membrane of your lungs that actually causes the serious damage. It damages the DNA and leads to cancerous growths, or can lead to cancerous growths. The HSE estimate that in the UK there are 2,000 fatal cancers per year caused by radon, leading to premature death. It's a serious matter, and for many years successive governments have kicked the tin down the road, and it's not being sufficiently addressed to my way of thinking. What are the legal requirements? Well, there's a number of threshold and action levels which are determined for both residential properties and for commercial properties. For residential, homes in the UK have an action level of 200 becquerels per cubic meter, but preferably a target concentration of 100 becquerels per cubic meter. How do we actually measure this? Well, we measure it within people's homes in a very simple device, track etch devices. You can write to the HSE and get these in the post. and a pair of track etch devices and the subsequent laboratory analysis and tests will cost you less than £100. They're small plastic covers holding an internal screen, CR39 plastic, which is the same as people have in their spectacle lenses. And these are coated in caustic soda. So when a radon alpha particle is thrown off, it collides with that plastic lens and forms a pit, hence the name for track etch. And the pits are counted and the time averaged number comes out. So typically these are left in a home for between 7 days for a short test or 90 days for a more authoritative test. And it's a very simple test, and it's you get very good results from them. How do we protect properties? Well, in the same way that we protect properties from other ground gases, but perhaps even better quality detailing and quality assurance. Here's an example of a property which we were called to do some radon testing in. This was a commercial property, so it was regulated by the HSC and the workplace safety regulations. And this was a property, part of a portfolio of offices that this particular company had. And as an employee, as an employer, it was looking at getting all of their properties radon tested. They got a quotation from a company who did a very low price and did a test in this porch and found that it was 370 becquerels. That's above the threshold concentration. As a consequence, the property owner wanted a more detailed investigation. So we were called in to do a more thorough investigation, and this is what we found: 900 becquerels, 1200, 1700, 1100, 2830 becquerels in those rooms. We found 7,830 in that one office space. So it is very specific to how rooms are used and the site-specific circumstances of a particular development. Putting a track edge in just the foyer of this building certainly wasn't a suitable tool for risk assessing. Okay, I see that I'm running over slightly, so I'll quickly go through the next slide. As Trevor mentioned, there were updated radon maps published at the end of last year. You can get those, you can dial into those maps through this website, where there is an interactive map which you can zoom into. And this is the snapshot of the Hertfordshire area. We've got High Wycombe in the bottom left here, Stevenage in the top right. And you can see the different colours represent the different concentrations of radon across the area. If there is a white tile, the chance is that a home will have only a chance of less than one home in 100 having a radon issue. The darker areas, that will change to 1 in 3. So Abbots Langley and Chesham are high risk areas, relatively speaking. Okay, I'm sorry, I've run out of time, but I'm happy to take questions. I just would point out that if you go to the GGS website, we run free webinars on a whole range of gas-related topics that may be of interest to you. So please visit that if you have an interest. Thank you very much for your attention, and let me know if you've got any questions.
We do have one question that's come in, Simon, from Ross. So he said, in your opinion, should all new houses have a gas membrane installed, regardless of where the houses are located, e.g. even in low risk radon areas?
That is a very sensible question. And my answer is probably not, because if there is a blanket requirement, then you're putting gas protection in where it's not needed. And if it's not needed and people think it's not needed, then the quality of installation will be very poor. And if you have a general industry quality control issue, then you'll have a poor installation where actually you've got a radon risk which actually needs to be properly managed.
Also, there been considerable changes to the maps and increases since 2022? Why are there suddenly these significant corrections now?
Right.
How did that come about?
This is how it works in practice. If you order a track etch device, then the laboratory will send it out to the home, and the homeowner will follow the instructions, put one in the lounge and one in the bedroom, and leave it there for 90 days, then put it into a sealed envelope and send it back to the laboratory. That laboratory will process it and send out a result to the homeowner, but they will also send an anonymized result to a health and safety executive with the postcode. So the health and safety executive get a stream of device results through time, and they update the maps on a regular basis in line with the risks that they see. So it is a continually evolving database, if you like, of radon hazard.
Okay, just a couple more come in. I'll do our guest first rather than RMTs. So from Kate Rich, what's the merit for barriers and extensions if the house isn't protected?
Again, an excellent question, and one we deal with on a regular basis. A modern extension will be built differently to the original house. Older houses, particularly Victorian houses, they will be drafty. They will have a ventilated subfloor void, and ground gases will be, if they're present in the area, will be safely vented. But if you're putting an extension on, which is, for instance, a raft foundation straight on the ground, then that may actually, and it's hermetically sealed with double glazing and tight doors and so on, but any ground gases coming in under that may actually enter the property. So the risk profile will change for that property as a whole as a consequence of that extension being built. And if there is a gas risk present, then it's better to have it protected. Some people will see that as being illogical, but there will be an improvement in the risk profile to the householder.
Okay, and finally, before I get to you, Trevor, I understand that you've got something to say on the radon maps.
Well, to be honest, I think Simon's covered it. I was just going to give the local picture, but he's covered it very well. Thank you very much. So I don't really need to say much more about that.
Well, that's great then. Okay, so last question on the board is: could any of these ground gases be harnessed and used as an energy source?
again, a really good question. We took part in a Environment Agency-led research project looking at former landfills and trying to identify those former landfills which still had gassing potential, and using low energy diesel low energy power packs generating electricity from that gassing source. Unfortunately, it was European funded research, and once the Brexit vote went through, the funding stopped. But there is potential to identify some of the younger former landfills which still have a gassing potential which can be harnessed to generate electricity. So yes, and the other thing I think is those former landfills may actually represent a very good location for solar farms, bringing them back into beneficial use.
Okay, we've got more questions rolling in. Do you have time to
I'm happy to carry on if people are wanting to ask.
In a new building where it's been identified as CS2 with a score needed of 1.5, is a ground bearing slab with gas membrane on its own satisfactory, or is ventilation beneath critical also? Methane and CO2 are elevated on this site.
The CS2, the guidance doesn't require it to be verified, and as a consequence, you may get the ground workers putting in a membrane. Although it may not be required by the point system in BS 8485, it is always good practice to put a pressure relief layer underneath the slab. So a single-sized stone layer linked to the outside of a property footprint would allow any gases to seep outwards safely. It's not an open void as such, so it's not going to give you the same protection that a block and beam floor and open void, but some sort of pressure relief layer is always advisable, even in CS2.
Okay, we could maybe combine the next two questions. So we've been asked, does a membrane need to be installed by a registered installer and a certificate issued? And someone else says, we often see poor installation, and is there an initiative for training being rolled out?
Yes, very much so. It's really frustrating to see membranes put in so badly time and time again on those marginal sites where it's perhaps slightly elevated carbon dioxide or methane, and you've got a CS2 situation, characteristic situation. It is always good practice, best practice, to have a qualified installer, and there are NVQ level 2 qualifications that are available, training which is available for installers. It only becomes a requirement at CS3 or above. The trouble is, if you are looking at verifying a unqualified installation, you'll find problems, and if you are a regulator, it is a main headache for you, I would think.
Can I chip in there and just say, probably one of the messages that's come across loud and clear for people like myself in building control is that we are a point of control that can prevent defects, especially where it's not a specialist installer. And so, you know, all our colleagues out there, we've got an inspection notification framework that we send out to the customer. We need to identify these sites, and we need to include inspection of the measures as a statutory inspection, statutory notification, and make sure all our people are up to speed on those measures.
Thank you very much, Trevor. That is really important. That would be very helpful. And the worst culprits are probably the smaller developers, because they probably don't have the understanding or the knowledge.
Excellent.
We've got a question about is it possible to share basic methods of providing protection for each level indicated on the maps? So are there different levels of protection for each, as it got darker on the map that you showed?
I would refer you to either the Health and Safety Executive radon pages on the website, or the Radon Council's website, which will give guidance on this. But there are two levels of radon protection which is required. It's called a basic level of protection, which is just a membrane and a radon trap underneath, or a what's the term? Advanced radon protection. And basically, the advanced radon protection is putting an extraction system onto that radon sump. So it's one or the other. And the good thing about radon is it is a chronic risk. It's not an instantaneous risk. So if you've got a test inside your property and you find that it isn't, it's above the threshold level, there are measures you can retrofit to improve the radon or reduce the radon risk. You can look at activating your sump. You can retrofit a sump into some properties. You can add a loft fan to put in a positive pressure within your property. You can add in extra ventilation. And all of these measures can build up to give you good reduction on your radon track etch readings.
Okay, as a final question then, any more questions, I'll give an email out in a post-event email there tomorrow. So in your opinion, can mechanical ventilation heat recovery systems have a meaningful impact on reducing gas levels?
Any positive pressurized system in a property will discourage ground gases getting in. Most gases will move by pressure differentials, and if you've got a positive pressure in your house because you've got a heat exchange unit or something of the kind that adds an extra few millibars of pressure in the house, it's going to help keep ground gases out.
Okay, thank you.
Right, well, it's been my pleasure to speak to you all. Thank you.
Well, thank you very much, Simon. Really, really interesting, as and testament to the number of questions that got asked at the end of there. So apologies, we ran over a bit there. Hopefully everybody managed to hang on and listen to them. So yeah, really appreciate you taking the time. It's been a really good webinar. Thanks to you, Rach, in the control room, and thanks for sorting out the glitches, and thanks for everybody's patience while we got going. So yeah, we'll hopefully get something together. Rachel, as always, will notify people of what's in the pipeline. I don't know if you want to mention anything about that, Rachel.
Yeah, so the next webinar we've got set up is for the 21st of March. That's going to be by Trevor, and he's going to give us a refresher on approved documents part F and L. So registration's open for that one now.
Yeah, might get 5 or 6 people to that. We never know until we see how it goes. It is a repeat of one we've done some time ago, quite a long time ago. So a lot of the audience probably won't have managed to see that. So we'll run that again, and then.
Yeah, I'll just say that everybody that's attended today will get a CPD certificate, albeit so check your inboxes for those, and we'll also give you details of GGS if you do want to get in contact with them with any follow-up questions or information that you would like.
I'd be very happy to answer any questions which come directly to me.
Excellent. Right. Well, thanks again, Simon, and thanks to everybody, and we'll see you all again soon. Bye for now.
Thank you. Bye.